Just about everyone knows that we on Earth are orbiting around our sun in a circular path due to the force of gravity. I mean, it's pretty much common knowledge at this point. We see it with the other planets in our solar systems and even planets of other solar systems. But a lot of us fail to realize why. Why does gravity keep us in a circular path instead of causing us to crash into other objects or just causing us to careen into space? Allow me to introduce you to the concepts of general relativity and spacetime. I know the idea of space-time kind of sounds out of this world, pun intended, but the concept is very simple. It's simply the combination of three-dimensional space and one-dimensional time into a four-dimensional manifold in which all objects in space exist. This four-dimensional cube is known as a tesseract, and it's basically the dimensions of space-time. General relativity is also another easy to understand concept. Without a mass in space, the plane lies flat, yet when a mass is added, it causes a warp in the plane around it. This bending of space takes place in our fourth dimensional space-time, but it's more easy to visualize with the three-dimensional model, or even better, the two-dimensional model. That warping that we see with both is what's causing other planets to want to go around the other one, kind of like a funnel. We'll be using the two-dimensional model in our example just to keep things a little more simple. For our example, we'll be using the fabric of a trampoline, and without a mass in the center, it lies flat. So when an object is moving on that plane, it continues to roll. But when we add mass, we can see that the fabric of the trampoline warps, kind of like how space-time would. So if we give an object an initial tangential velocity, it will start to orbit. If the object is initially traveling too fast, it'll simply bypass the object's gravity and go into space, whereas the opposite is true, and if it has too little velocity, it'll simply crash into the object. In that example, we did see the smaller object crash into the larger object at the end, but this is simply due to the force of friction that's on the fabric. In actual space, there is no friction, or air resistance at that, so the objects will continue to orbit each other. So next time if anyone asks you, why don't we just go crashing into the sun? You can now explain to them the concepts of general relativity and space-time, and you can even tell them that it's like we're in a giant funnel.